In this video, we're going to have a look at the input file which is created by PATRAN when you create such models using this interface. Uh, it might be seeming far-fetched to you that I'm loading all this information on you in the very first week that you actually start playing with the software, but consider this, that it's important to know from day one as to what the software is doing behind the scenes, so that when you get stuck and you are having to troubleshoot, then you know where to find the right files and you don't have to wait for someone to help you with that. So this is basic information that is very essential whether you would be working with this program later on or not, because all the programs are set up in almost the same way. So they are obviously doing some work in the background that you generally don't see, but it is quite important for you to know where it exists and where it happens. So if you remember correctly, then when we created this example one with 1 element and 4 element database, we saved it in the working directory, and this working directory was for me in PATRAN folder. So what I did is I have arranged it in date modified, so you see all the ones that we worked on today, starting from 1 element onwards up to here. Now, one thing that I would have wished to show you when we were running the analysis is that when you hit run or analyze the model after creating a job, you will see that a bunch of files are created in this folder, and it's quite dynamic because there are a bunch of files that are created. Some of them are useful and the others are discarded off after the analysis is over, and then all you're left with is only a very few number of files which you can see here in this list. So all these are related to 1 element, and then you have all these files which are related to 4 element. So if you look at the list, you have a F04 file, an F06 file, a text document, an Exceed font database, which was the XDF that you were XDB file, which you need for the results, and a BDF file. Now the BDF file is the one that is the input file which is created by you in the pre-processing. So all the information about the model is in here. Let's open one of these input files. Let's go for the 1 element one because that's easier. We know we have only 1 element. The BDF file can be opened in any word processing software. So you can use it with the EM editor or whichever one you want to use. I'll just open with EM editor because it's nicely organized in this way. And I can open multiple files in the same window. Of course, it's free for basic use, and then after that it starts prompting you for all kinds of licenses, but yeah, well, that's your choice what you want to do with it. So if you look at the file here, you will see that there are some bunch of information here. These are all starting with the $sign, which means they are comments. Now if you remember, there was a section which was called direct text input in the analysis section when we were setting up the job. So if you see that these are the different cells: NASTRAN system cell, file management, executive control, then you have the direct text input for bulk data. So this is where all these cells are present, and if you type in some information into the user interface, it would show up here under each and every section. Now, the way the input file is set up is that it first gives you the kind of analysis you want to carry out. So sol means solution sequence. So you have the solution sequence 101, which is for the linear static analysis. So if I go back to PATRAN now and I say, okay, analyze, and I go back to analyze, you might not have noticed it at that phase, but if you do solution type and linear static, right under here it says solution sequence 101. If I change it to non-linear static, solution sequence becomes 106. So these are inbuilt codes that you can't change and that are used by NASTRAN to understand what you want to do with the model. Then you have to add this line C end every time you have to finish with the executive control section, and then the other section starts. You have a title of the file and subcase, what are the entities of the subcase, what did you ask for, how many constraints or boundary conditions you have, how many loads you have, etc. Then you have the direct text input for this case, which begins with the bulk. So all the information that you want from your model is here. So if you think about it, what PATRAN does is that it helps you create a geometry and create elements. But what needs to go into a solver is only the elements. So geometry has absolutely no significance at all in the finite element formulation because everything is discretized in these element forms. So if you see carefully here, nowhere does it show up with geometry. The first thing you start with is the elements and the properties. So you see the elements are the type and the type C rod. So this is the element. The number of the ID of the element is 1. And then you have, if you look at the syntax, then it will say, okay, what kind of element it is, and it's also 1. And what are the nodes that are the coordinate system would also be involved somewhere here. And then you will have the nodes that are connecting it. So the nodes that are making the element are 1 and 2. The property associated with this element is called prod. This is the name of the ID of the property. This is the ID of the element on which it is applied, or basically the C rod. So this corresponds to C rod, this corresponds to P rod, and then you have a area which you wanted to supply. The material also has to be included here, so that's material property 1 here. So if let me correct myself. It starts with, let's start with materials. We have material 1 which has certain properties. Property rod 1 is related to material 1 and area. And then C rod 1 is related to property 1 with the nodes 1 and 2. So this is how the whole element is set up. Then of course you have nodes. So nodes have to be defined somewhere. So here you will see the nodes. So grid means grid nodes. So the grid 1 is basically giving you the coordinates of the node 1, and grid 2 gives coordinates of the node 2. This is what you exactly enter. This is how you see it in the input file. Then it says you have a SPC add. So how many boundary conditions you have, how many loads. If you remember, then we had applied the load and boundary condition twice. Once to the geometry, once to the model. So it takes it as 2 times. So the first constraint was number 1, which meant that I'm going to add all these to 1, 2, 3, 5, 6, and I'm going to fix them. So there's nothing that will move. Then you have, and it is applied on the node 1. And the nodal forces would be ID1, which was P. It is applied on node 2, and the values are given over here. So there's in 0, you have 10, 1. This is just an ID number. You can look at the syntax later for more details. And this gives you the magnitude, and this gives you the vector along which it is applied. So you have the vector x, y, z, and it's only applied along x, as you see here. So this is the basic setup of the input file. So you have some bunch of information that is mandatory to provide. Then you have to set up your elements, your properties, your materials, your nodes, your boundary conditions, your loads, and that's about it. That's all you enter. And of course you must mention what kind of solution you want to see from this. So this is the PDF file. We just want to take a sneak peek into it. Of course, you will also get some other files after the analysis is run. F04 file is mostly a session file, so it saves everything into it. Then you have the F06 file, which is going to give you the results. So if I just double click into the F06 file, you will see here that it has its own format. If you scroll down, you will start seeing some results. It also gives you a model summary, so you have only 2 grid points and 1 element. And here at the base, you will see that the there are SPC force resultants, which means the constraints. So the constraint forces are 1000 in negative direction, which gives you a verification that your model is correct. The maximum forces, maximum displacements, you can pick up here, and the node-wise results for displacement and forces will be given afterwards. So you can look at all these things to find out what is the problem. Now say suppose you have a error. This is the file which is going to show you that there is an error and what kind of error it is. It will give you a code. Sometimes it's quite cryptic because you won't know what that code means, but you can easily find it in the documentation or if you do a good Google search. So just as a small closing, let's just look quickly at the PDF file for the 4 element system. Everything else remains the same, except for that now we have 4 elements. So they define the 4 elements in the same way. You have only one material, but you have 4 properties, and all these 4 properties, so the P rods are associated with each element C rod. So you have C rod which is joining 1 and 2, then you have C rod which is joining 2 and 4, then 4 and 6, and 6 and 8. So you see the odd numbering, of course, because of the equivalency. You could have chosen which one to get rid of, but if you do it automatically, it may have some detailing with numbers. Then it also gives you all the grid points. So you have 5 grid points with different coordinates, axis, coordinate locations. So you can see that here. And the rest remains exactly the same, except for the node at which the load is applied, and the node at which the boundary condition is applied may also be different. So this is a very simple sneak peek into the PDF file and the F06 file, which is nothing but the results file. Next time you run an analysis, make sure you're looking at this folder so you see all kinds of files that are generated during the analysis as well.